in terms of data and how to analyze with this data, what sort of methods and technologies play a role? And is it relevant to manufacturing industries? I know it is relevant to manufacturing industries, but from a champion like Aditya Birla team, I would like to hear from Mr. Srirangarajan. Being Aditya Birla being a very large organization, you will have multifaceted, interesting challenges to address with the data. If one plant is not sufficient, you may have some 40 or 50 odd plants giving you data. So how do you manage with that data?
Thank you, Ravi, for the question. Talking of how we are trying to use data, in all my plants, we have implemented data historian. We have AspenTech working. We're working for about 6-7 years now. So recently, we have thought of building a model where we say, okay, I'll build a soft sensor for my quality. I think the focus in our business is to say, how will I improve operational efficiencies? And probably something else which concerns all of us in the world today, how to make the world more sustainable. So sustainability is another key thing that we try and look for. And we're trying to leverage technology in both these areas. So while I talk of data, coming back to data, we have kind of developed a soft sensor. It's a continuous process, corrosive process at that. Business is successful. So the arguments can be, oh, 50 saal chala, what's so great? So we tried to kind of come up with what benefits it can give people, why we should use data. And I think we've been able to do that very successfully in the last year and a half too, talking of so-called data analytics. We built neural models from using Aspen data. We've been able to predict quality. Typically in the olden days, or rather earlier days, if I say, correct myself, we would have said here, lab results will come, and then I will go back to my process line, change the process parameters. Okay, all this takes about 48 hours. I mean, with everything that you have today in terms of computing, in terms of, like you just now talked about the hard disk and things like that, I'm able to give you instantaneous predictions. So we are able to say within 10 minutes, I can tell you what is going wrong or what is probably going wrong. And we're able to predict to almost 98% accuracy. So by doing that, instead of taking action after 8 hours, I'm taking action after maybe 10 minutes. So we are really using data to that. And talking of results, we believe we've got almost 7% improvement in my quality, 7% improvement in quality. That's the kind of, and we're just talking of one parameter. We have 17 parameters, of which about 8 of them are absolutely important. And so by doing just tuning that one parameter, oil pull unit, if I can say so. So I'm able to improve my quality and the so-called A grade by about 7%. So we are able to prove this in one plant. Then we will roll it out in all other plants, all other lines. We have about 25, 28 lines across Southeast Asia. So we'll try and roll it out everywhere for this particular so-called parameter. And we see wonderful results coming out of such a model. That's how we are using data, to give you an example of how I'm using data.
Excellent, Srirangarajan. So 17 parameters, you pick one parameter and you fine tune on it. You are able to bring down the reaction time, the action taken time from hours to minutes. So that's a huge achievement with respect to data. So where the data analytics can play a role is where you are able to make such kind of impacts in manufacturing. So I think Srirangarajan has put it very naively. I think, he would have struggled, which are those data to pick up, right? And then how that can be fine-tuned. So that is where the wisdom of the business, comes into picture. That's where I'm sure that the technology elements, the people who are, and when I talk about technology, it is not IT, it is the real R&D teams which would have sat down, they would have broken their head to pick up and sieve through that data and pick that data which is going to impact and brought that 7% improvement in the quality, and I mean in terms of your fine tuning and helping in improvement in the quality. Now I am sure, having done this, you are choosing again the very best proven approach, piloting in one and then taking across the globe and then repeat it. This is what all these world-class organizations do, and Aditya Birla is also doing it, is no exception to that. Wonderful, wonderful. How do you deal with IoT sensors and machines?
Key thing is to be able to get the buy-in of the guy on the shop floor and say, oh, this is what will give you benefit, make him accept, get him to do that, and then say, here, okay, I'm able to do this. So today we are talking of, notwithstanding that I will say they are old plants, we kind of putting up sensors everywhere. We want to say IoT. We have embarked on a project, I think, where we think that we will get about 4 to 5% kind of savings, where we're talking of saying, okay, chillers, cooling towers in a process plant like ours, that's one of the thing that we need to do. So we built a kind of digital twin around this. All of them are sensorized. We're able to get data, digital data everywhere. Gentleman spoke starting saying digitalization. So we kind of trying to get that entire thing. So now I have the entire chiller system of a plant on my PC. I'm able to see that. And so we're talking of saying we probably will make about 800 kilowatt hour per day savings. That means almost about 5-6% of energy consumption savings. I mean, it's just about started. The pilot has started. We believe that we should be able to deliver this kind of benefits. And again, the first one we piloted in an Indonesia plant. This I'm piloting in my Gujarat plant. I want to say all the chilling systems, chillers, everything will be on system. Can I do this? And maybe after about 3 months, I say, okay, fine, this is working for me well. Just do a kind of replicate everywhere. This is how I'm going to use IoT.
Oh, fantastic. So you touched about two things. One is with respect to the legacy systems and using the IoT sensors. You have identified the chillers and also the cooling towers. Obviously, that is the one part of it. The second part of it is you have built a digital twin around that, right? These are the two aspects which many people they struggle to get it. Why I'm saying this, how you go about putting IoT sensors in legacy systems? How are you addressing, I don't infringe onto any rights of the OEM because it is trouble for myself. Tomorrow also, I need to get into my own contractual agreements with respect to servicing of the machines so that I don't end up into problems. So I need them for my own survival. So how are you putting IoT sensors there? Secondly, how can you build a digital twin when OEMs are not going to be supportive with respect to their data models? At least you need a 2D model of the equipment for you to build those kind of digital twins. This is where technology companies are challenged, where to put my digital twin. They have on one side super duper technologies. I can build this. I can do this. These are all the software which can help to build me a 3D or even what sort of ultra modern models. But where are those bones and skeletons for me to build? How did you go about doing this?
See, I think we got the OEMs to be part of this whole story. They were given the first option of saying, okay, can you do this for me? If they could not do it for me, we got on board, and we have a small little program called AAA program where group wide some startup companies are kind of listed on that AAA program. So all startups, small companies would want to work with us. So we took one of them and said, oh, here we want to do this. So with each of the OEM that I have as this cooling tower, your chillers, so we worked with them. It has taken us about a year and a half to come where we are. It's not that it just happened in a day. It has taken us a year and a half. So we got all of them on board, and today we're saying everything is seemingly working. So it's about getting people to accept.
Excellent. Excellent. Yeah. Um, easily said, but very, very difficult to achieve. And I really value that, because this is an area where people find it very difficult, and still they are finding it very difficult. You have made it look very, very simple.